So hello there. This is a simple recording to tell you how to do basic field cementing calculations. So this is an example of a basic lab report or a cementing recipe, slurry recipe that you would receive on the field in any cementing program. The important data to see here is select a brush. Okay, so the important stuff you need to know is number one, what your slurry recipe is for. So this one is for the lead slurry. We'll get into what a lead and tail slurry is later on, but it's just important to know that this one is for the lead slurry. Secondly, you want to know what your density is. So the density is 15.2 ppg, pound per gallon. And the sack weight is 94, which basically means this is a neat cement slurry. They're not using a blend, so this is a neat slurry. Later on, when we get to how you would do calculations for a blend, we'll get into that. So the other important data is your mixed fluid and your mixed water ratios. So let's just highlight that, and most importantly, you have your yield. For this slurry, we have 1.26 cubic feet per sack, which is not the standard. The standard for 15.2 ppg slurries is 1.16 feet cube per sack, but we do not have that here, so we'll just delete that. Anyhow, so that's the important data, and this stuff, the lot numbers, we'll get back to them later on after doing our calculations. So the starting point of any cementing calculations is that you need to know your volume. Which is typically in BBL or barrels. So let's assume that our volume is 100 barrel. Secondly, what you need to know is whether your cementing calculations should be based on fly mixing or batch mixing. Now that is important because you need to know your dead volume. So for this example, since this is a lead slurry and lead slurries are typically fly mixed, we're going to consider a dead volume of 5 barrel. We'll get into what exactly a dead volume is when we look into cementing volumes, but let's just, a brief description would be, this is the amount of mixed fluid that would be left in the tank after you're done pumping your slurry. So this is the volume which would not be pumped, which would not be mixed with cement to make slurry. Anyhow, so let's move on. Let's move on with the calculation. The first step of any cementing calculations is to convert this volume into a unit you can use. Now we are going to use cubic feet. So 1 barrel is 5.6146 cubic feet. So 100 barrels will give you 5614. Let's just cubic feet. So you have your volumes right away. The first thing you need to calculate is how much cement you would require. How much dry cement you would require, cement powder. So the first thing for that is your yield. What you need for that is your yield. So our yield, notice the units there is in cubic feet per sack. What it means is that 1 sack of cement gives you 1.26 cubic feet of slurry once you mix in your mixed fluid, this thing. So let's calculate the amount of cement that we would need, number one, right? So we have our volume, which is 561, let's just round it off to this much cubic feet. Now, as you must have noticed, your yield is simply in cubic feet per sack. So keeping the units consistent, or rather, trying to understand what's happening, if you make 5615 cubic feet of slurry and you need to calculate the amount of sacks of dry cement required to make that, what you need to do is divide your volume by your yield. So that is 5615 cubic feet divided by 1.26 feet cube per sack, which will give you, let's actually calculate that, 5615 divided by 1.26, it gives you 4,456 sacks of cement. Okay, so the next step is to calculate your mixed fluid volumes, this thing. So in order to get that, that's a very simple calculation. You have your sacks of cement. What you do is you simply multiply your sacks of dry cement with your mixed fluid ratios. So let's just put underline here to tell you this step number. Okay, 4456 sacks multiplied by the mixed fluid ratio, which is 5.941 gallons per sack. This gives you a mixed fluid volume of, let's multiply it by 5.941. So it gives you 26,475, 26475 gallons. Okay, so in order to convert that from gallons to barrel, since we do want to maintain some form of consistency, we'll divide this number by 42. 42 gallons is 1 barrel. So that gives you 630. Let me check that again. Was that 630? Yes. So that gives you 630 barrel of your mixed fluid. Now, be careful regarding mixed fluid and mixed water. So mixed fluid is your water, fresh water, or salt water if you're using salt water, but basically your base water plus chemicals. So that's your mixed fluid. Anything that you would add to your dry cement to make slurry, that's your mixed fluid. Mixed water is just water, like plain flat out water. So be careful with that. So let's scroll down a bit. You have 630 barrels of mixed fluid, but let's look at the dead volume here. If you make only 630 barrels of mixed fluid, you won't be able to make 100 barrels of slurry, because 5 barrels of your mixed fluid is going to get left behind. So you need to add 5 barrels of dead volume to your mixed fluid, which would give you 635 barrels of mixed fluid that you need to prepare. Okay, if we have 635 barrels of mixed fluid, how many sacks of cement are required? Well, we need to work our way back up to this point. So simply go back with your calculations, just use this number again. So when you multiply your sacks of cement with your mixed fluid concentrations, you get your mixed fluid in gallons. So what we need to do is simply, sorry about the noise, we would add 5 here, it gives 635, and then we are going to multiply that by 42 to get your mixed fluid in gallons, which is 26685. 26,685 gallons. This is simply being converted. Just multiply that by 42. Okay, so this is the amount of gallons that we need to make. Previously it was 26,475. Anyhow, so what we're going to do is we'll divide this number by the mixed fluid concentration, which is 5.941 gallons per sack. To get your sacks of cement. So we're going to divide this number, or mixed fluid in gallons, by our mixed fluid concentration, which is 5.941, which gives us 4492. So 4492 sacks of cement, considering our dead volume. So we will call this our revised sacks of cement. Now, this is the number we're going to use in all of our calculations, so we need to keep this in mind. So let's write our important data here. So our revised, to be honest, let's just delete this part. 4492. So let's just write it here. Our revised cement sacks are 4492 sacks, or mixed fluid in barrel is 635, or 635 barrel, or 26685 gallon. 26685 gallons. Let's delete this entire part so that we have a little more space to do our calculations. Now this is just getting started. It's a bit time consuming, but the calculations are relatively simple. Okay, so you have your dry cement requirement right here, and you know your mixed fluid requirement. So the first thing that you need to calculate now is how much water that you need. What is your base amount of water? Because that is what you're going to mix, right? Okay, let's select the pen again, and the pencil. Let's select a brush. Let's choose a different color this time. So what is the water requirement? Okay, so you have your mixed water calculation here, mixed water concentration here, which is 5.861. So very simple, just multiply your cement sacks, which is 4 for revised cement sacks, because we are considering our dead volume, 4492 sacks, multiplied by your mixed water concentration, which is 5.861 gallons per sack. Now notice that this number, your mixed water concentration, is always less than your mixed fluid concentration, because when you add your chemicals to your mixed water, which is just flat out water, the volume would increase slightly. Also, you can note here that all of these chemicals are dry chemicals except for this one, which is a wet or a liquid chemical. So with dry chemicals, usually there's not a big increase. Not usually, there's never a big increase. But if you were to add a anti-gas migration agent, for example, you would see a big rise over here. You could get something like 6 point something gallons per sack in your mixed fluid. But anyhow, this is our basic calculation. So let's actually calculate the water requirement. Let's clear this up. 4492 multiplied by 5.861 gives you 26327. 26327 gallons, or if we divide it by 42, you're going to get 627 barrels. Let's change our color here. 627 barrels of water. So this is our water requirement. Why didn't we take the decimal place? Well, when you're mixing cement, or when you're mixing 100 barrels of cement, you're not really going to measure out in a fraction of a barrel. You need to keep things pretty rough. Depends on your volumes. Like 100 barrel, you won't really bother with like half a barrel, but if you have something like a plug where you're only pumping like 20 or 25 barrels or even less, then you might wanna consider that, especially with your retarders and fancy slurry systems. Anyhow, so that's not what we're looking into. So let's switch back to black. You know how much water that you'll consume. Now our next step is to calculate the chemicals. So let's go for the first one. You have your D47, which is your antifoam. Over here it says 0.01 gallons per sack. VBWOC just means volume by weight of cement. So the volume of D47 by weight of cement. We'll get into what that means. You'll understand once we calculate for it, right? So we have 0.01 gallons per sack multiplied by your sack of cement. And how many sacks of cement did we have? 4492. 4492 sacks, which is going to give you 44.9. Okay, so the thing to note here for your wet chemicals or liquid chemicals, for example D47, which is your antifoam, your concentrations are given in the unit gallons per sack, volume by weight of cement. So what that means is that you do not have to do anything. Your units are pretty much set by multiplying your revised sacks of cement by your concentration, and you would immediately get your result in gallons. So if you multiply your dry sacks of revised sacks of cement with your concentration in gallons per sack, you would get 44.9 or gallons of antifoam, which is D47. So nothing much to do here. But with dry chemicals, let's say D20, which is bentonite. Okay, they're adding bentonite to a 15.2 ppg slurry. This is probably done because they're using a lower concentration of flak, perhaps. The flak is pretty high as well. So maybe they were hoping to make the slurry more viscous by adding bentonite at 0.4 concentration, which is already pretty high. Anyhow, so for bentonite, or any other dry chemical, really, your concentration would be given in percentage by weight of cement. So what that means is that of this 4,492 sacks of cement, or the total concentration, the total weight of cement in your slurry, 0.4% is going to be bentonite. So the dry material, the entire dry material weight is going to be largely cement, but of that, 0.4% is going to be bentonite. So just keeping out that technical or complicated stuff, what you need to do is simply take your concentration in percentage, which is 0.4%, or by the way, 0.4%, let's not write that as percent. Let's write 0.4 divided by 100, which basically means 0.4%. Multiply that by 4492 sacks. But over here, as we saw, that this is percentage by weight of cement, and this percentage is in terms of sack weight. So what we can do is that a better explanation would be to think of this slurry in terms of a single sack. So when you add 1 sack of dry material, 0.4% is going to be bentonite. Like, let's say we just mixed all the dry chemicals together and we put them in water, 0.4% of that dry material is going to be bentonite. So we already multiplied, where did our cursor go? So we already multiplied our concentration by our sacks of cement, because this is our total amount of sacks, and we multiply that by the sack weight, which is given here, 94 pounds. 94 pound. So let's calculate that. Let's just write that here. So 0.4 divided by 100, multiply that by 4492 multiplied by 94. It gives you 1688. Let's recheck that because we have a memory of a goldfish. Okay, this should be a 9 pounds of bentonite. So 1,689 pounds of bentonite need to go into this mixed fluid. Let's calculate the next chemical, just one more, and then we'll, because basically all the dry chemicals are going to have the same calculation. So this is going to be so D167 is your fluid loss control agent, or FLAC. So this is your FLAC. So 0.32 divided by 100. Multiply that by your revised sacks of cement in sacks. Always remember to write the units. Like without that, you'd have a tendency to mess up. So let's calculate what that is. 0.32. Okay, no. 0.32 divided by 100. Multiply that by 4492 multiplied by 94. Let's actually recheck that, whether we're doing it right. Yep, we are. So 1350. 1350 pounds of D167 are required in this slurry. And you would go on about, like, doing the same calculations for the other chemicals as well. For example, for D65, which is your dispersant, what you would do is 0.15, which is your concentration, divide that by 100, multiply that by your revised sacks of cement, and then multiply that by your sack weight, which is given over here. So you can go on about it with your dry chemicals, and this way Just remember to divide your concentrations by 100 since they're given as a percentage, and since this is by weight of cement, you need to multiply your sack weight, which is 94 pounds. In case of any cement blends, let's say you had a silica blend or any other kind of blends, this sack weight would be different. It could be 100 pounds. 100 pounds. So instead of 94, at that point you would multiply that by 100. But of course, this is just a simple introduction of cementing calculations, so you won't bother by that. So and with your liquid chemicals, let's say you had another chemical, you had gas block over here, which is D620, or you could have D700 or whatnot. They would give you a concentration like 0.15 gallons per sack. Simply multiply this by your revised sacks of cement, and you would get the gallons of your liquid chemical that you need to add in your mixed fluid. So this is the basic way that you would calculate for your cement slurries. The difference between a fly mix slurry and a batch mix slurry is solely based upon your dead volume, because in a batch mixer your dead volume is going. Okay, let's do a brief intro of what a fly mix slurry and a batch mix slurry are. So a fly mix slurry, you would use a fly mixer. A fly mixer, what it does is you prepare your mixed fluid separately in a different tank. It takes that liquid mixed fluid, water plus chemicals, and it combines it with your dry cement slurry in a small tank, usually 6 to 10 barrels. It could be lower than that, it could be a bit higher. It combines that, and instead of keeping it in that tank or pumping it in batches or storing it, you would pump it directly downhole into the well. So if you are considering any dead volumes, you would consider the dead volume of the vessel that you're storing your mixed fluid in, not your pumping units or whatnot, because it's going to be very minute. So the amount of dead volume is solely based on your mixed fluid tank. And number two, the most important thing is we only took 100 barrels, but usually slurry volumes can go all the way up to 1,000 barrels. Even you could have a massive slurry volume, to be honest. So for higher volume slurries, you also need to know the amount of blend or dry cement that you need. So for fly mix slurries, it's very important to know that yes, you do need this amount of water. This is the amount of chemicals. This is the amount of chemicals you would need, but the cement amount, the amount of dry cement, is not your revised cement. It is the original cement volume that we calculated and deleted in this scenario, but I'm sure you can rewind this video and find out. So this is how you calculate your fly mix slurry volumes with chemicals. And I did promise to tell you about lot numbers, so I will right now. When you have your sack of cement, when you have your sacks of chemicals, they are usually made in batches. Now, cementing companies or cementing service providers rarely make their own chemicals, or rather they never do. What they do is they source these chemicals from external vendors. After sourcing them, well, there's a supply chain involved, and these chemicals could be expired, or they could be, anything could be wrong with them. Their properties vary quite a bit. You need to be especially careful when you consider your lot numbers with retarders, for example, because you need to know which lot of retarder did the cementing company use in their lab report. Let's say for this report they use this batch of retarder, but on the field you use a different batch. It was 719336, for example, and it had properties slightly different. You did add the same amount of retarder that the lab guy added, but in his small sample, but you could have vastly different properties. This would affect your thickening time. We'll get into what thickening time is and whatnot in later videos, but it's going to affect your thickening time. So instead of getting 5 hours and 20 minutes, you could get something like maybe an hour, or maybe you could get something like 7 hours. So really, you need to worry about your lot numbers as well. So what I do usually is that after making my calculations, I would calculate the Of course, I would do this on an Excel sheet, not on paper, and not like this. I would write the volumes of chemicals. For example, the 47, we need about 45 gallons. What I would do is I would write how many cans of D47, that is the basic unit that you would have. Now 47, it comes in jerry cans of 5 gallons, so I know that I would need 9 cans of D47, and I would write the lot number right here. So when I'm checking the cementing chemicals, right there and then I would know which lot number I would use. And yes, you need to check every single can for the correct lot number. Anything can mess up. D47, to be honest, it really doesn't matter, but with the other chemicals, it kind of does. Especially with bentonite. Like in this report, they just wrote field sample, but that should not be done. You should write your bentonite sample, where you got it from, because if your bentonite is different from the lab, it could vastly affect your cement slurry properties. So anyways, that's pretty much it. If you have any questions, leave them in the comments. I'm sure I could have done a better job in explaining all this, but hey, it is my first video and it's a part of a big series, so good luck with your cementing calculations.